All right, chapter 4, lesson 6. This is rational numbers. So let's get rational. So when you hear the word rational, you think of things that, well, make sense. So if I were to say something like, you need to be more rational, it means you need to make more sense, use more logic. So rational numbers are numbers that make sense. Okay, you can use them in everyday life situations. It's very sensible numbers. So what is a rational number? It's any number that you can write as a quotient, a over b. Remember, quotient is the result of division. So as a quotient a over b, where a and b are both integers. And of course, b cannot be 0 because it's in the denominator. We don't want zeros in the denominator. So what's all that fancy schmancy stuff say? It basically means that if you can write the number as a fraction, then it's a rational number. So if it can be written as a fraction, it is a rational number. Now, numbers are sort of like cars. We can describe cars in different ways. For example, you say, that car is an SUV. And you could say even more further detail, like that SUV, okay, is a red SUV. Okay, and then we could say that red SUV gets 19 miles per gallon. Numbers are kind of similar in that way. Okay, they can belong to different groups. Okay, so starting off with the most basic numbers. Okay, the natural numbers. The natural numbers are all of the regular whole numbers, but not 0. Okay, so 0 is not a natural number. So natural numbers are counting numbers. 1, 2, 3, 4. Keep going. See, as long as it does not include 0, it's a natural number. Whole numbers are all of those natural numbers, so it includes the natural numbers, and 0. That's pretty much it. So all of those 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah, 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 plus 0 means those are the whole numbers. Now, integers includes all of the natural numbers. It includes all of the whole numbers. And it includes the opposite versions of them. So -1, -2, -3, -4, etc., etc., etc. Then there's the rational numbers. Now, the rational numbers, what we're talking about here, includes the natural numbers. It includes all of the whole numbers. It includes all the integers you can think of. And, fractional parts. So if I were to say -2.5, that is a rational number. Now over here in this weird little island right here is the irrational numbers. Okay, the irrational numbers are kind of strange, and we'll talk about them on the next page. But first, let's get some rational examples. So let's think of some numbers that could be rational numbers. So if I were to say something like, 2.3, I can write that as a fraction. If you read it closely, it says 2 3/10. So 2 3/10, or 23/10. So I can write that as a fraction. It's a rational number. Even something like -3, that is a rational number because I could write that as -3/1. I've written it as a fraction. Other examples would be things that like any decimal that terminates. So terminating decimals. And what does that mean? That means basically the decimal, it has an endpoint. It stops somewhere. So if I said 3.43456, and that's it. There's no more. That is a rational number. That can be written as a fraction. It won't be a very pretty fraction, but it can be written as a fraction. Also, decimals that have a repeating pattern. Those are also rational numbers. Whoops, I put 2 R's. So numbers like 0.3 repeating. Remember, that's like 0.333333, etc., etc., etc. That can be written as a fraction. It's 1/3. As long as it has a repeating pattern, it can be written as a rational number. Now let's look at the integers. So some integer examples. Now, remember, integers is included in the rational numbers. So things like -5, that works. That is an integer. It's also a rational number because I could say -5/1. I could say 3. That's an integer. It's also a rational number because 3 over 1. Okay, I cannot say 5.2. That is not an integer. That's a no-no. Remember, integers do not have fractional or decimal parts, so that would not be a good example. Now remember, whole numbers is a subset of the rational numbers and the integers. So I can say things like 5, that's a whole number. It's also an integer. Okay? It's also a rational number. I could say 7, that's a whole number. It's an integer, and it's also a rational number. I could even say 0. Right? 0 is a whole number. It's an integer, and it's a rational number. Because remember, 0 over, well, anything, it's still 0. So it can be written as a fraction. It's a rational number. Natural numbers is another subset, okay, as long as it doesn't include 0. So natural numbers are 1, 2, 3, etc., 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 etc. All of those can be written as a fraction. 1 over 1, 2 over 1, 3 over 1. So they're all whole numbers, integers, and rational numbers. Now let's move on to irrational numbers. Irrational numbers are bizarre. Very bizarre numbers. For irrational numbers, if you have a decimal that never ends, and there's no pattern to it, it's irrational. Okay, so if you have a decimal that never ends and there's no pattern at all, it's irrational. So something like 2.5361398. There's no pattern repeating there. It's just random numbers. Call it number barf. Also, if you take the square root of anything that's not a perfect square, so remember your perfect squares are like 1, 9, 16, 25. So if I take the square root of a weird number, let's say like 13, do you know what that is off the top of your head? Ooh, well then that means it's an irrational number. If you actually type it in a calculator, it'll give you a decimal that goes on forever with no repeatable pattern. So it's irrational. And of course we all know our favorite irrational number, pi. Okay, don't forget about that little guy, pi. He is the most famous irrational number. 3.1415, etc., etc., etc. It goes on forever. There's no repeating pattern. It's irrational. All right, so let's work with irrationals, or work with rationals, excuse me. So first up, equivalent fractions. Remember, rational numbers are numbers that can be written as fractions, so we'll be dealing a lot with fractions, and I might call them fractions more often than I call them rational numbers. All equivalent fractions have the same value, okay? They just look different. For example, I could say that I ate half a pizza, or I could say that I ate 4 out of 8 slices. I still ate half a pizza, I just said it in 2 different ways. Another example would be if I had like 2/6, or 1/3, or -3 over -9, or 100 over 300. Hey, all of these are equivalent, especially that one. Remember, the negative over a negative makes a positive. Hey, all of those simplify down to 1/3. They all have the same value. It's kind of like saying hello or hi in different languages. They sound different, but they're all meaning the same thing. Now, with negative fractions, it's important to point out that if a fraction is negative, there's 3 different ways to write it. You can either put the negative with the numerator, or you can put the negative with the denominator, or you can write the negative out to the side like this one seen here. You cannot make both of them negative. If you want to have a negative fraction, the numerator and denominator cannot both be negative. Okay, it's either one or the other. That's it. Okay, because this would mean a negative over a negative, and that makes a positive. So it's not even a negative fraction. Okay, so how do we get equivalent fractions? Well, you multiply the top and bottom by the same number. So if we had 4 over 7, we could multiply the top and bottom by the same number. So 8 over 14. Ta-da! Equivalent fraction. Very nice. We could also multiply the top and bottom by a negative number if we wanted to. So times -3 times -3. That gives me -12 over -21. Ta-da! Equivalent fraction. Okay, the negative and negative will make a positive, which we started with 4/7 once you simplify. So both of these are equivalent fractions. You just multiply the top and bottom by the same number. Finally, you thought we were done, but absolutely not. Okay, we got a word problem. Okay. So let's say the Flash is running a race with Superman. The Flash is running at 37 feet per second, and he sees Superman run past him, so the Flash has got to speed up. Okay, he speeds up to 102 feet per second, and it takes him 5 seconds to speed up to get that fast. How fast did the Flash accelerate? So we're going to use this formula. A equals F minus I over T. A is the acceleration, F is the final speed, I is the initial speed, or you can think of it as the starting speed, and T, of course, is time. So let's plug in some numbers. Okay, we do not know what the acceleration is. We're trying to find that, so we're going to leave that as A. The final speed is 102 feet per second, because that's what he finished up in the problem with. He started at a certain speed, and then he sped up, and now he's cruising at 102. Subtracting the initial speed. Initially, he was running at 37 feet per second, and then he had to speed up because Superman is just so fast. And it took him 5 seconds to do that. So, with rational numbers, we have to treat the top and bottom kind of like it was a grouping symbol. So we have to do what's in the numerator first, we have to do that subtraction, and then we can divide by 5. So let's go ahead and do that. 102 minus 37 is 65. And then we're going to divide by 5. 65 over 5 is 13. And the units for this are acceleration. So acceleration has kind of funny units. It's 13 feet per second squared. That's the units for acceleration, distance over the time squared. So the Flash had to accelerate 13 feet per second squared in order to catch up with Superman. Okay. Some simple math. Superman is much greater than the Flash. Okay. Definitely true. I mean, come on. Look at the Flash. He looks silly. Superman, yeah, he may look a little bit silly, but he could punch a hole through a wall and he shoots lasers out of his eyes. So, yeah, simple math. All right, I'm Mr. Bork, and that was Rational Numbers.